Hi everyone, I'm Shahin. I'm Principal Machine Learning Consultant at DiUS. That's my 9-to-5 job, but what I'll be talking about is Synthius, which is one of the startups that I'm co-founding at the moment. So this is what we work on after 5 usually, and the weekends as well, so it keeps us awake. The idea here is basically I will try to talk about the business problem behind what we are doing so that everything makes a bit more sense. So I will be limiting this talk to asset management. So usually the companies who are involved in different assets, what you find on the streets, you know, power poles, pipes, different machinery. These are really expensive assets, and they need maintenance. And sometimes these maintenances are enforced by regulations, but also they have to do it regardless, because if these assets stop working, the cost is paramount. So just imagine if the power poles are not working, the whole town won't have electricity, right? So that's the type of and the scale of problems that we are talking here. When we look at the inspection of these assets, it's actually very, very expensive. Sometimes you need specific experts that need to do all these inspections. And of course, they are always time short. And also we know that if there is a fault in any of these assets, it's very, very costly. So they have to regularly do that. Sometimes they do it continuously using IoT sensors, and sometimes it's done on schedule. But regardless, these are the things that need to be done, regulated by the government, and also for the actual company, so that they don't get any fines, so that their whole infrastructure works. The example that I would talk about is power poles, because that's something that everybody will understand, and then we will move to a few different examples. But obviously, computer vision can come very handy in these problems. You can use computer vision to automate the inspection process. Just imagine that if you can go and collect the data one way or another, you can do the process of finding the fault in the assets automatically if you have a good computer vision model. But usually the problem is that the faulty scenarios are very rare in the world. So because they are regularly maintained, that means that we don't get to see a lot of different defects. And as a result of that, we don't have good data sets to train computer vision models that can look at, let's say, images, or any machine learning model that can look at what has been collected and just automatically flag different things that need maintenance. So obviously the solution can be to generate more data. Everybody is talking about Gen AI. This is the right time to generate more data for such applications. But that's not the path that we will be taking, and there are reasons for that. So I've been trying to generate some images, especially for defects, for rust and other types of defects on power poles. This is what you see, and I spent probably half an hour generating these 4 images. But you know, you might be able to spend a lot of time coming up with a single image that works well for you, and it might take an hour of your own time, as well as you need good computers to do that, and so on and so forth. So although generative AI is very promising, it seems like it's not actually working for our problem, and that's not how we will solve this problem. So firstly, as we all know, the inference time is very long, so they are very slow to generate different images. We don't have any control over what comes out of these, because we always start from noise, and it might give you something. It might be good or it might not be good. You have to, through the process of trial and error, try to make it better and better, and it's a very cumbersome process. And at the end of the day, you might end up having 5 photos, and that's not what we are going for here, right? And also, for these images, how are we going to label them? So that's another story, right? So these models will give you the image, but there is no label for them. So unfortunately, that was not the way that we solved this problem. So maybe in the future, we have an eye on these models. So many exciting stuff is happening every day, but that's still a little bit early to generate reliable data for training such models. So what's our solution? This is where we think we are a little bit innovative. We tried to think out of the box. We had a very good problem in hand. We wanted to solve that the right way that makes business sense. So the way we solve this problem is that we are using game engines. And in game engines, you can model anything that you want using normal programming. And if you have access to artists, if you like, they can help you with coming up with the right assets that you can import into these engines. We are generating the assets outside the game engine, import them into the game engine, and then we start randomizing and generating more data from what we've already imported in them. So randomization is a very powerful technique. So we can change anything that we want in that environment. You can change the illumination. You can have full control over where your camera is, what are the specific criteria of your camera, different variations of the object, whether it is colors, whether you want to replace one piece with another. So these are all the things that you can easily program for these environments to do. We are using Unity for this specific application. Programming of that is in C#. There is a Python wrapper on top of that we can use. We use C# directly because we feel comfortable with that. But also you can basically do anything you want. Also, one good point about these game engines is that the physics is already implemented in there. So collision, gravity, things like that. So if you are creating a video, especially for a physics simulation, these are really, really powerful environments. Of course, one of the applications are games, but there are so many things that can be done in these environments, and they are actually open source as well. So that was the path that we took. Once you create your scene, you can easily randomize that. You can write your code, and you can actually generate millions or billions of images and videos, or even other modalities in these environments, if you like. That's the path that we are taking. So we are just constantly randomizing, taking different photos, and also we've written custom code that labels the data for us as well. So I will show some of those examples. But again, I think that's different. We are not aware of anyone else who's done that before. I think NVIDIA is starting to work towards that. The idea was before NVIDIA had even thought about this. So this was growing in the back of our mind for quite a while. So these are some of the images for power poles that you can see here. So it's as you can see, it's an environment that we've totally designed. The look of it, we can improve as much as we want. We can work on that as much as we want. But also we can, we've written algorithms that basically, it's kind of simple. So these are all generated and are Unity. And you can see that I've just basically drawn the bounding boxes on top of that. But Unity will export all those in a format that we can easily read in a standard way, right? So this is an object detection problem. We've designed different bits and pieces of a power pole. We can easily basically design faulty things that we want to detect. We can replace that with a good one, take more photos, know where that is in the photo. So we have the objects, we have the semantic segmentation if we want to as well. But yeah, regardless, we design this first, and then we randomize and take photos, and we can generate millions of photos in a matter of few minutes, actually, and use that to train a model. Here I've used, so the photos you see here, these are real-world images, actually. And as you can see, these were what we were trying to design for. So the images that we've designed on the left-hand side, we tried to make it as close as possible to the real-world images that we will see in the future. And As we all know, domain adaptation is a problem, so you just want to make sure these are as close as possible to each other. The results you see here are the results of a YOLO version 7 model that is trained on the synthetically generated data. And then we just pass the images to them and just ask it to give us the object detection bounding boxes. And it's working actually really, really good. And we, there's an iterative process, because once you pass your real-world images to these systems, to these models that you've trained, you realize that there are scenarios where it actually doesn't do a good job. So it's an iterative process. So you see where it's not working, you go back, you try to change your simulation and maybe add a little bit to that. And by the end of that, after several iterations, you get to a point where these work really well. So this was the first application, so power poles and using object detection. So imagine that you have a drone, it's flying, it can take photos, and basically you can automate the whole process if you like. And it can detect if these insulators are faulty or not based on the photos. And you can easily know where to go and try to do the repair and maintenance. Second example, so this is water pipes. The way it works in practice is that they send a very small camera through the water pipes, and it's constantly taking photos and videos. And they actually analyze those photos manually at the moment. Especially with the older pipes, terracotta pipes, the problem is that after a while they get misaligned. So these are basically like brick-like parts that are put next to each other. And after a while, because it's usually underground as well, so there is a bit of misalignment and there is leakage. And that's a very common problem in old houses, actually. So this is the problem that water companies try to deal with. So what we've done here is that I've just shown a single image. So basically, we try to model how things will look like when you go through that pipe. And there's a bit of misalignment here, as you can see, which is here. And again, as we are generating these images, we are also generating the semantic segmentation mask as well. So they are all exported in terms of millions of images. You can model different things in there if you want. We just stopped there because it seemed to work very well. And again, this is something that we can work on, but if you look at an example in real world, this is how they look like. So it's a little bit different than what we've designed. Our design looks like it's perfect. Everything is good. But in reality, the photos that you see, they have like writing on that. You can see some cracks. There are things that are not exactly looking like what we have designed for. And as a result, of course, the model is not doing an awesome job, but it's actually giving you where the misalignment is, and that's what it is designed for, right? So it's actually what we were really impressed by the fact that although the images are not that close to reality, we are still getting good results. And the third problem here is cracks in concretes and pavements. So this is a problem that is very common. If you look down while you're walking, you see so many cracks and concretes. And councils are actually in charge of those. And there are regulations that enforce them to keep track of them and make sure that they go and do maintenance, whether it is on the roads, whether it is on sidewalks. So this is the problem that we are already working on. We had to spend a lot of time making sure that we can generate the cracks randomly in a way that it looks very real. The crack looks like what you would see on a street, if you like. And we have ways to randomize this and generate a lot more. And obviously, we are generating the mask as well. These are some images that are from the real world. We see that it's working well for the scenarios that we have, but we are not there yet, unfortunately. So when you look at the images that are available in council, they look like this. And unfortunately, our model is not doing a good job yet. So it is an ongoing process for us. We haven't got to a point that we are very comfortable with the model. And by the way, for the semantic segmentation models, we are already using a BAIT model, which is a 2022 model that was proposed in ICLR as well. But regardless, I think the idea is working. There is research that supports this. And they suggest that for scenarios where you can collect some data, but your data is limited, if you can enrich that data with your synthetically generated data, that's where you get the best performance from these models. And yeah, for the scenarios that we've modeled, we really didn't have much data. So we only had a couple of examples that we used for evaluation mostly. But yeah, so that's basically the idea on what we have been working on. So the idea is actually is a very strong idea in our mind. I think we can use this for other scenarios as well. So it's not just applied to asset management. Any scenario where the event that you are after is rare, you can use simulations and modeling. Basically, there are scenarios where you might be able to go and collect your data, but the problem is that it might be very unsafe. So industrial areas, as an example. So you don't want people to go and inspect those areas. It might be even dangerous for them, or at least not pleasant. So we can generate the data for such scenarios. Sometimes labeling the data is very expensive. You might need experts, as an example, doctors and medical specialists. So if we can sit with them and just understand how they go and label the data and what good versus bad looks like, we can actually model that and generate more data of any type, if you like. So, and also for many scenarios, we can't really take photos of people's faces, as an example. So privacy might be an issue, and you might try to address those problems using these techniques. One powerful point about these game engines is that if you are a good developer and you know how things work, you can get them to export different types of data for you. So you can get them to export 3D data, point cloud. You can even get to a point where you can export images that look like thermal images or X-rays and so on and so forth. So the sky is the limit, basically. So what you have in mind can be implemented. Yeah, so that was the idea and what we are working on. And if there's any question, I'm happy to take one.
Just wondering, so before with that
Thanks.
photograph poll image, you
Yep.
had the ones that you generated, photograph poll, the ones that you generated, and then the ones that you got with a drone.
Yep.
Is there a process where you sort of say, okay, this is where the camera was in Unity, and this is where the drone is in real life, and sort of saying that's where the object is, and then you compare it to that subset of images, so you kind of know where the object is, so that you only compare it to.
Yeah. So it's a bit of a manual process, to be honest. So when you go and randomize these, so you can randomize the position of your camera. You always try to make sure it looks on the object, right? So that's something that you wouldn't probably change much, but you can define the range that you want to move around, right? So you can say from this height to this height, and basically a randomizer would go and randomly change the number of the position of that camera. And there is, again, it's a manual process. So we had to look at the results, try to generate more, see if it looks like what is available in real world. And we actually trained several models just to see, because by the look of things, sometimes it looks okay, but the models don't do a good job. And you get to see where it's not doing well. So there's a bit of manual process to get it to work well. But you are absolutely right. So you have to look at the real world. You have to look at the scenarios where you want to cover and try to model it in your modeling environment. Yeah.
Just to confirm, the generated image, they are also generated through prompt, just like for images.
No, we are using a game engine, and it's pure programming.
Okay.
So it's exactly how games are developed these days. So you have an environment where you can import different 3D objects, if you like, or 2D object in there, but you can even control different things using normal programming. And we use C# for that, for this specific environment called Unity. And that's how games are designed, actually, yeah.
Technically,
you can, yeah. There is some modules that use GPT to try to, work with Unity as well. So you can basically hook them up if you want to as well, yeah. Sorry, I couldn't hear.
Have you tried Gaussian splatting for this?
Gaussian splatting? Oh.
What is it?
It's like you take a bunch of photos of an object from different angles.
Ah, yes, right. No, it's something that we have in mind. It's actually really, really interesting point, right? So basically the idea is that you take different photos from different angles from an object, and it generates the 3D model from that object. So that is a technique that can be used for creating the assets that goes into this. But we've used artists to generate these assets. So we haven't been involved directly into that process, but we haven't used images or anything of that sort either. So we are basically just saying, hey, this is how this looks like, try to go and generate it, and we just give them feedback. Yeah.
You said you spend a lot of time generating the cracks. Are those like 3D modeled cracks, or is it just like texture?
No, it's texture on top. Yeah, yeah. It looks exactly the same. So, yeah.
Because I guess you can do bump mapping.
Yeah, yeah, you can. Yeah, yeah. Yes.
Just a quick one. So at the end of the whole process, you have a classification of something being faulty. Is that correct?
Correct.
Have you guys sort of, other than the classification, are you guys looking at explanations or anything? And the reason I ask is my son's an engineer who does a lot of this forensic engineering, and I know when he writes the reports, it's one part of the process is obviously identifying the issue, but then you need to justify the issue. So my question is, are you looking at all to maybe sort of go that next step further from a sort of label or a classification to maybe an explanation?
We actually haven't thought about that. It's actually interesting, especially for scenarios where you have physics involved. So just imagine that you model a heartbeat, right? And you measure it in a time series data. But because you've designed that in a simulation and you can change different parameters, you can see how the data looks like when you export that. So again, we've just put a little bit of thought in that, but we are also business driven, right? So we have to have the right problem to work on. But yeah, definitely. I think there are good things in there.
Yeah, I used to do this kind of stuff in my previous job at Silverfont, and the business process that it fits into is often to pick up things that the human inspector misses, basically as a second check, because there are regulations that require that the images be looked at by a human. So yeah, then the human can figure out the explanation or anything you can't do with the model. But we used to talk about the scary scenario where, you know, the pole was literally on fire, and because the model has never seen that before, it thinks it's fine, right?
Yeah, that's true.
Defects. And there's this terrible problem that every asset of the same type looks basically the same, but defects, every asset can be broken in a million different ways, right? So the defects are hugely variable as well as potentially very rare. Yeah.
That's right. And fire is actually very well modeled in game engines as well. So, yeah.
Yeah. Some good explosions in there, I bet.
Yeah. Yeah.
I'm really keen to understand just got a couple examples about the lighting.
About the lighting, yeah.
Did you guys model obviously some daylight, but also different angles and infinite randomization?
Yeah. So there are several types of lighting that is already modeled inside game engines. So some of them are pointy, some of them look like sun is shining. So it's actually very, very simple and easy to change those. And also you get a bit of reflection from the background as well. So whatever you design as your scene in the background, you can even get it to basically have some reflection on the objects and define the material of your object and how reflective they are as well. So these are all the things that can be done. Again, you know, bear in mind you have to try to get your model working. There's so much creativity that you can have if you can see that that's the scenario. So do we collect images at nights? Probably not, right? So
we do something very similar with Unreal and Nanite when Nanite came out. Nanite's a lighting engine within Unreal. But what we went down a rabbit hole because of different lighting conditions and the reflection
That's right.
I'm wondering if you had that same issue with this.
Not with the three problems that I talked about here, no. No. And again, I think you can change the type of lighting as well and see if it makes any difference, that's for sure. And the material of the objects as well, yeah. Okay. Sure.
Yeah, I'm here. So my question was, I suppose at the moment it seems like it's quite a manual process in the conversion of these sort of, I guess, the electricity from coal, let's say, you're getting an artist to do it, and then they have to code it up and everything else. I suppose, do you think that that will change eventually within your business? And I guess what technologies do you think would help you make that change? Make it more automated, so someone can maybe go and upload an image and then they automatically get something that they can get
Yeah.
images from.
Yeah, so there are models that basically take a photo of your of whatever that you are modeling and converting that into, let's say, 3D point clouds or 3D objects and such. And then you can add randomization in there, right? So there are techniques, and generative AI techniques are actually helping with these things. So there are a lot of models, not a lot, but NERF models and the other ones that are trying to do that. But that's basically just to try to automate one step at a time, right? So another problem that we are dealing with here, and we haven't actually started those, is that what if we have a model that takes photorealistic images, the synthetically generated ones, and convert them to something that looks a lot like real-world examples, right? So that way we get better results, but you need to train that model. So I think machine learning can help with the process of automation in this, in different steps, but I would say one step at a time, and time is short for us, so we have to try to prioritize all the time as well. Yeah.
All right.
Okay.
Speaking